In this video, we are going to look at tutorial sheet 4 questions. Okay, so this is math for second semester. So we start from question 1 there. All right, so question 1, they're saying explain what you understand by the following. So the first thing that we've been given there is probability distribution. Okay, so what is a probability distribution? So a probability distribution simply describes, or you can say a probability distribution is a distribution that describes how the probabilities of a random variable are distributed over its possible values. Okay. So it can also be classified as providing the likelihood of different outcomes occurring in an experiment. So there are two types of these probability distributions. Okay, the first one is the discrete. Okay, discrete probability distribution. Okay, so the discrete probability distribution is for countable outcomes, and then we have examples such as the binomial distribution. Okay, we have the Poisson. These are discrete probability distributions. And then the other example is the continuous. Okay, the continuous probability distribution. So this continuous probability distribution is for uncountable outcomes. So for example, we have the normal distribution. Okay, so that's what we can say on the probability distribution. And then 2, they're saying define probability density function. Okay, so a probability density function is simply a function that describes the likelihood of a continuous random variable taking on a particular value. Okay, so that's what a probability density function is. Okay, so since continuous variables have infinite possible values, the probability of any specific value under continuous random variables is always 0. Okay, but the area under the curve, okay, or over an integral, which we are going to be using to find this PDF, okay, gives the probability. So in a mathematical sense, we say that the probability of x being between, okay, a and b is equals to the integral from a to b of the function f of x and then dx. So we're going to be using these integrals here to find the probability density function. Right, so I've explained that one. And then what is the cumulative density distribution? Okay, so the cumulative density distribution, okay, the cumulative density distribution is just simply a distribution that gives the probability that a random variable x is less than or equal to a particular value of x. So it is given by a capital letter F like this, which means that we have a probability of x being equal to or less than a certain value of of x. So this is what we call as the probability density function. Okay. All right. So for discrete random variables, it's given as f of x is equals to the summation, okay, for all k values that are less than or equal to to x, and then the probability of all the x is equals to k. Okay, and then for continuous random variables, this f of x is given as the integral from minus infinity all the way up to x of f of t and then dt. Okay, so these will start making sense when you start solving questions. Okay, for now, they're just definitions. All right, so that's what the cumulative density function is. Okay, the other one that we have is a discrete random variable. Okay, what's a discrete random variable? So a discrete random variable is a variable that takes on a countable number of values. So we defined what a a discrete random variable is, and when we're doing statistics, the introduction to statistics. Okay, so this is just a variable that takes on a countable number of values. Okay, and then um, these values often represent things like the number of customers in a store, or you can say the number of heads in a coin tossed. Okay, yeah, so that's the discrete random variable. And then what is the expected value? Okay, so the expected value, which is also known as the mean of a random variable x, is the long run average of its outcomes if an experiment is repeated many times. Okay, so you get the random variables. Okay, you multiply it with the probability of that random variables. Okay, so the long run average of the outcomes of the experiments, that's what we call as the expected value. Okay, so for discrete, okay, random variables, it's given as, okay, the expected value is equals to the summation, okay, of all the random variables with their probability. Okay, so this P and then you have big X is equals to small x simply means the probability of this X. So in some books, it's just given as the probability of X like this. Okay, so capital X is equals to X. These here are the same. Okay, and then this is under discrete. So if you are considering now under continuous random variables, okay, the expected value of X is given as the integral from minus infinity all the way to infinity of X multiplied by f of X and then dx. So this is the formula that we're going to be using under what? Continuous. All right, let's define what a binomial distribution is. Okay, so what is a binomial distribution? So a binomial distribution is a distribution that models the probability of getting a certain number of successes in a fixed number of independent what? Trials, where each trial has only two possible outcomes. Okay, either it's a success or it's a what? A failure. That's what a binomial distribution is. Then in mathematical forms, it is given as the probability, okay, the probability of x is equals to n choose x, and then we have p to the power x, and then we have q, okay, to the power n minus x. So this q here is the same as 1 minus p. Okay, so this is the probability of success. This is the probability of failure. So if you add probability of success plus probability of failure, you always get 1. So where there's q here, you can also put q is equals to 1 minus what? P. So in some books, you find 1 minus p. So this is the formula for what? For the binomial distribution. So this n represents the total number of trials. Okay, x represents the number of successes. P represents the probability of success in one trial. And then this Q, or 1 minus P, represents the probability of what? Of failure. All right, so that's that about the binomial. And then we define the Poisson. Okay, so the Poisson distribution is a distribution that models the probability of a given number of events occurring in a fixed interval, okay, of time or space. So it assumes that these events occur independently and at a constant average rate. Now, and then the formula for Poisson, you are going to see that the average or the mean is going to appear. So the probability of x under the Poisson distribution will be given as, okay, mu to the power, uh, okay, so let me use the symbol for average. So you're going to say mu, okay, to the power x, and then e to the power minus mu divided by x factorial. So this guy here, this symbol here, okay, is the what? Is the average or the mean. Okay, and then E is just a number. And then X is the actual number of events that you're what? You're considering. Okay. So remember I said it models the probability of a given fixed of events occurring in a fixed interval of time. Okay. Assuming that these events occur independently at what? Constant rate. No wonder you can see the mean in the formula there. All right, so those are the definitions for these terms. Okay, for more, you can refer to your lecture notes, okay, or I'll upload the written solutions for this part for question 1 so that you can just read through the definitions and then you can be able to answer questions there. Right, so we go to the next question now, which is question 2. So question 2, they're saying determine by given reasons which of the following are probability distributions and which ones are what are not. So for something to be a probability distribution, okay, it means that all the probabilities P of X should be between 1 and what? 0. So this is the first condition. And then the second condition is that, okay, the summation of all the probability Px should be equals to what? 1. So if all these guys, okay, are satisfying this condition here, we're going to say they are probability distributions. If they are not, we are going to say they are not. Okay, so let's look at this one on A here, this table here. So they're saying we have X. Okay, this random variable X takes 1, 2, 3, 4, 5, and then it also has its probabilities there. Okay, so they're saying the value of K is 30, is 0.30 like that. Okay, so we see that this first condition is met as all these probabilities here, they are what? They are greater than, or I mean, they are greater than 0, okay, but they are less than 1. Okay, so this condition is met. What about the second one? The second one says the summation of all these probabilities here should be 1. So let's try to add 0.25 plus 0.20 plus 1, I mean 0.15 plus the K we've been given at 0.30 plus 0.10. Okay, so let's add this and see if they're going to give us 1. 0.25 plus 0.2 plus 0.15 plus 0.3 plus 0.1. Okay, so when I add, it's giving me 1. Okay, so it means it also obeys this condition. So it obeys both of the conditions. We're going to say yes. The first one is a what? A probability distribution. Okay, and then let's look at the second one, which is on B. Okay, so on B, okay, on B, we have this guy here. So we have the random variables here, 1, 2, 3, 4, and then we have the probabilities that have been given in form of beta. And then they've said this beta is just 1 over 13. Okay, so let's find the probability here where there's beta. It will just be 1 over 13. The probability here, okay, maybe I should be writing them there. Okay, so the probability here will just be 1 over 13. The probability here where there's 2, it will be 2 multiplied by 1 over 13. So that will just be 2 over 13. Here it will be 4 multiplied by 1 over 13. It will be 4 over 13. Here it will be 5 multiplied by 1 over 13. So that will be 5 over what? 13. So we see that all these probabilities here are greater than 0 but less than 1. So this one is satisfied. What about this one that says their summation should be equals to 1? So here I have 1 over 13 plus 2 over 13 plus 4 over 13 plus 5 over what? 13. So let's add this. So common denominator is 13. So we're going to have 1 plus 2 plus 4 plus 5. So if I add 1 plus 4, it's 5. 5 plus 5 is 10. Plus 2 is 12. So 12 divided by 13. We see that this one here won't be equals to 1. Okay, so because the summation is not equal to 1, it's equals to 12 over 13. Okay, so that's 0.99 something. It's not equals to 1. We're going to say this condition here, the second one, has not been what? Has not been met. So we're going to say no. The one on B here is not, okay, is not a probability what? Distribution function. Right, so I think there's C here. I forgot to add it here. So, but you can use the same techniques here to find out if it's a probability distribution or it's not. Right, I'm pretty sure you're going to find it's a probability distribution because it's going to obey this one and this one. So try it out. Right, so I go to question 3. Okay, so question 3, they're saying a derivative of 6 paracetamol boxes contains 2 expired boxes. A nurse makes a random opening of 2 boxes from this derivative, okay? The random variable x denotes the number of expired boxes opened by the nest. A, find the probability distribution table of x. B, represents this distribution as a graph. Okay, so for us to find the probability distribution table, we have to know the distribution that we are going to use here. Okay, so this probability distribution table is such a table like this one here, where you have the random variables and their probabilities. That's what they mean there. Okay, so to find this table, we first of all have to know the probability distribution that you're going to use here. Okay, so here we notice that this question or this scenario, okay, this question or this scenario will follow what we call as a hypergeometric distribution. Okay, why is it a hypergeometric distribution? It's because the nest selects the boxes without replacement. Okay, when that nest selects one box, she won't put back that box. Okay, she'll just open it. Okay, so the nest selects the boxes without replacement. So it's going to follow what we call as the hypergeometric what distribution. So the hypergeometric distribution, if you want to find the probability of x, you're going to say this is equals to, okay, capital letter X, and then I'm going to say uh capital letter what am I doing now? Okay, so capital letter X there, okay, and then small letter K X here, okay, and then multiplied by, we have capital letter N minus C, capital letter K, then here we have um N, small letter N minus A, small letter X. Okay, so this one here was supposed to write big letter X like that. Big letter X. So here is supposed to be like the X. And then you divide all this, okay, by N, like a small n here. So these here are what we call as combinations. Okay, so the hypergeometric distribution is given by this formula that I've written here. So let me explain what each of these mean. Okay, so the capital letter N, okay, means the total boxes that you have. Okay, total boxes. Then the capital letter X means the number of expired boxes. Okay, expired boxes that you have. And then we have the small letter n. So the small letter n, it represents the number of boxes that you're going to be choosing. Okay, so the chosen boxes. Okay, and then the small letter x. Okay, the small letter x will um the small letter x will mean uh the number of expired boxes opened. Okay, the small letter m means the chosen boxes, and then the small letter x means the number of expired boxes that are what? That are opened. Expired boxes open like that. Okay, so we're going to be using this formula to find the probability. So remember they said we find the probability distribution table for X, right? Okay, so in this pack of 6 paracetamol boxes, they're saying 2 are what? Are expired. So let's get the data. So the capital letter N, we said the total boxes, they're just 6. Okay, and then capital letter X, we said the expired boxes, which is just 2. And then small letter n, we said the chosen, okay, the chosen boxes. So these ones, they're going to differ, okay? You can choose from that 6, from those 6 boxes, okay, that you have, you can either choose 0 boxes that are expired, or you can choose 1, or at most you can choose what? 2. So this n is going to be changing. And then the small letter x, okay, the small letter x, let me write it in this way. The small letter x, we said it will be the number of, um, it will be the number of, the number of boxes, okay, that are expired that will be opened. Okay, so that's what we're going to be putting here. Okay, I think this small letter x here is the one that will be changing. So it will take 0, 1, and then 2. And then I said the small letter n, it will just be the number of boxes that you choose, okay, from the total. So this one is not going to be changing here. The one that will be changing is the small letter x. So this one will be constant to just be 2. Okay, and then this one here is the one that will be changing. You can pick 0, you can pick 1, or you can pick what? 2. So we can find the probability now since we have all that data. Okay, so let's find the probability that from the 6 boxes we choose 0 boxes that are expired. So probability of 0 will just be equals to, okay, the capital letter X is 2, so I'll put 2, 0, and then here it will be capital letter N minus capital letter X. So that is 6 minus 2, that will be 4. Then here it will be N minus X. Okay, so the N is 2, the X is 0, so it will mean I just have 2, then divided by capital letter N, 6, and then N, 2. All right, so these are combinations. Okay, so you punch this on your calculator. So you say 2 combine 0. If you want, you can write it like this. Then multiplied by 4 combine 2. Okay, and then the product of these here, you're going to say divided by 6 combine what? 2. Okay, so you do this on your calculator. All right, so let me punch these values now. Okay, so when I punch these values, what am I getting? Okay, so when I punch these values, I'm getting this. Okay, this value here, the 2 combined 0 is giving me 1 multiplied by 4 combined 2 is giving me 6, and then divided by 6 combined 2 is giving me 15. Okay, so this is going to give me the probability of 0.1, 0.4, I mean. Okay, so it means the random variable 0 has the probability of what? 0.4. What about the probability of getting one box, which will be expired? So this will be 2, 1. Okay, this remains the same to be 4, 2. Even this one here to be 6, 2. So this is going to be equals to, okay. Did I say this one remains the same? I lied. Okay, so this one here now, the x is 1. So it is 2 minus 1. So this one here has to be 1. Okay, this one has to be 1. Right, so let's find the answers. So what is 2 combine 1? It will just be 2 multiplied by 4 combine 1. It will be 4. Divided by 2 combine 6, it still remains 15. So this is 8 divided by 15, which will give me 0.5333. So this is the probability of the random variable what? 1, or picking one boxes, which is what? Rotten, expired there. And then let's find now the probability of picking 2 boxes that are expired. So if my x there, okay, the smaller x is 2, it means here there will be 2, even there will be 2. Okay, so it means I'll have 2 combine 2, and then here I'm going to have 4 on top, and then down there it's just going to be 0, because the n, remember, is what? 2. And then we're also getting our small letter x as the 2, so that will be 0, and then divided by 6 combine 2, like that. So this is going to be equals to, okay, so what is it? 2 combine 2. 2 combine 2 is 1, multiplied by, what is it? 4 combine 0. It is also 1, divided by 6 combine 2 is 15. So this is 1 over 15, which will give me 0.0667. So this is the probability of the random variable what? 2. Okay, so now we can come up with this probability distribution table here. Okay, so I'm going to erase these guys here. Okay, so let's drop the distribution table here. Okay. Like that. Okay. car. So this will be X, and then this will be the probability of what? X. So we have three random variables, 0, 1, 2. So the probability of 0 is 0.4. Probability of 1 is 0.533. Okay. And then the probability of 2 is 0.0667, like that. Okay, so this table that I've drawn there is the probability distribution of what? Of X. All right, and then B, they're saying represent this information on a graph. So the graph that we're going to use is just a bar graph, okay? So we are going to put the x's on the x-axis, and then the px, we're going to put it on the y. So it's going to be something like this. Okay, so I have 0 there, and then, okay, so maybe 0, we can put it inside there, and then I have 1, and then I have 2. Okay, and then on the probabilities here, just take a look at what you have. 0.4, 0.5, 0.06. So it means you can go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, like this. So this is Y, then this is X. Okay, and then from there we can just plot. Okay, so at 0 we have 0.4. So at 0 here, I'm going to go to 0.4 like that. Okay, and then at 1 we have 0.53. So at 1 here, just going to go slightly above 0.5 there, like that. Okay, and then at 2 we have 0.06. So 0.06 is somewhere here, just below here, before the 0.1. So that one is going to be here. What have I done? That one is going to be just here below, like that. Okay, so this graph here represents the probability distribution that I have there. All right, so that's the graph. And then from there, we can go to C. So C, they're saying what? C, they're saying find the probability that one or none of the expired boxes was what? Was opened. So what is the probability that one or none? So probability that one or none means that we are adding the probability of 0, okay, and the probability of what? 1. So the probability of 1 or none means that x is less than or equal to 1. So if x is less than or equal to 1, it means it can be 1, or it can be a number which is less than 1, which is what? 0. So this is going to be equals to the probability of 0 plus the probability of what? 1. So what is the probability of 0? 0.4 plus the probability of 1, 0.533 is equals to. So you add those, you're going to get 0.9333. So this here is the probability, okay, that 1 or none of the expected expired boxes were what? Opened. All right, we move. So the next one now, they're saying find the mean. Okay, so we said the mean, which is the expected value of x, is just going to be equals to the summation of all the x multiplied by the px. Okay, so this is going to be equals to, here I have 0 multiplied by 0.4 plus 1 multiplied by 0.533 plus 2 multiplied by 0.0667. Okay, so this is going to give you 0 here. Okay, and then plus here is going to give you 0.533 plus 2 multiplied by this is going to give you 0.1334. So you just add this now. So you're going to get 0.6667. So this here is the expected value. Okay, so expected value of x is just 0.6667. Okay, and then we also find the variance. Okay, so the variance is given by this formula. So variance of x is given by, okay, variance of x is given by the expected value, okay, the expected value of x squared minus the expected value of x, and then you square it outside. So notice that this here and this is not the same. Here the squared is on the x, here the squared is outside. So meaning you first find the value of expected value of x and then you square it. So we've already found this. So we just have to find this part. Okay, so this part has a square on the x. So it means you have to square the values of x here. So the values of x are 0, 1, and 2. So you square the 0, square the 1, square the 2. Okay, and then what are you going to find there? Okay, so here you can even change that. This is expected value of x squared. So this is going to be equals to, this here will still remain 0. This here will still remain 0.533 plus, this one will change because 2, okay, 2 squared there is going to give you what? Okay, 2 squared there is going to give you 4. And then 4 multiplied by 0.0667, okay, what is going to give you? It's giving me 0.2668. So you add all this, you're going to get 0.8. Okay, so this is the value for that. Okay, so you can erase whatever we have here. So we're going to say the value for this is just 0.8. So it means our variance of x will just be equals to the expected value of x squared, 0.8, minus the square of the expected value of x, 0.666, then squared. Okay, so what are we going to get? Okay, 0.8 minus, let's square this. 0.66, oh, 0, 0. What's happening to my calculator? That stopped working. Okay, so 0, okay. So 0.8 minus 0.667 in the brackets. Okay, it's giving me 0.445. So subtract this, I'm going to get 0.3555. So this here will be my variance. Okay, so I found my variance here. Found the mean, found the variance. And then the standard deviation, we just know it's the square root of the what? Of the variance. So this is the variance. So 0.3555. So find this square root of this. It means you found your standard deviation. So I'm finding 0.5962. So this here is my what? My standard deviation. So it means we are done with question 2. We go on to question what? This was question 3. We are done with question 3. We go on to question 4. All right, so question 4, they send the number of patients who go to a certain clinic between the hours of 20 hours and 21 hours can be modeled by random variable x having the probability distribution given by this here. Okay, all right, so this probability distribution, let's say x is equals to a small letter x is equals to k, and then we have 3x plus 1. Okay, so the first question is find the value of k. So how are we going to find the value of k? So since here they have said this is a probability distribution, so we know that the summation of all the probabilities should always be equals to what? To 1. That's what we said. We said the summation of all, okay, the summation of all the probabilities should be equals to what? To 1. So we're going to sum up the probabilities there, but we are going to be replacing this x that you can see here with different random values that we have there. Okay, so the first one will be k, and then 3 multiplied by 0 plus 1. So I'll replace this x with a 0, and then I come and replace with 1. Okay, so it will be like k, okay, it will be like k, and then 3 multiplied by 1 plus 1 plus k, 3 multiplied by 2 plus 1 plus k, 3 multiplied by 3 plus 1, then plus k multiplied by 3 multiplied by 4 plus 1. So the summation of all these probabilities we are saying should be equals to what? 1. Okay, so it means 1 is going to be equals to, so this will be k, this will be 0 plus 1, so k multiplied by 1 is just k, and then plus, here to be 3 multiplied by 1, 3 plus 1, 4, so this will be 4k. Plus, here to be 3 multiplied by 2, that will be 6 plus 1, 7. 7 multiplied by k to be 7k. Plus, here to be 3 multiplied by 3, 9, plus this 10, so it will be 10k. Plus, and then here to be 12 plus 1, 13. 13 multiplied by k to be 13 what? Okay, so you add all these now. Okay, so when I add all that, I'm getting what? Okay, it's giving me 35k is equals to 1. So we can use this to find the value of what? The value of k. Okay, so it means the value of k will just be equals to 1 over 35. Okay, so this here will be the value of what? Of k. Right, so once we find the value of k, we can use it to find the distribution, okay, and represent it, one, in tabular form, like we did on the previous question, and then two, in graphical form. Okay, we also did that on the second question. So this tabular form, it means it just needs us to put the random variables and their probabilities. Okay, so this will be in tabular form like this. So I have x there, and then I have p x here, which is the same as p capital letter X equals to small letter x. Okay, so we have 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. Like that. That's what we have. So what is the probability of this? So the k is 1 over 35. Remember? Okay, so we have 1 over 35, and then there it will be 1 over 35, which is the k, and then inside to be 3 multiplied by 0 plus 1. Okay, so this is what we are going to be doing, but we are just going to be changing the value there. So this here will just be 1 over 35. Because this 3 multiplied by 0 is 0, and then 1 plus 0 is 1. 1 multiplied by 1 over 35, it gives you 1 over 35. And then on 1 here, okay, it's just going to give you 4 over 35. You can confirm that. On 2, it's going to give you 7 over 35. On 3, it's going to give you 10 over 35. On 4, it's going to give you 13 over what? 35. Okay, so you can even find the decimal numbers for these guys, okay, so that to be easier for you to plot it on the graph. Okay, so let's find the decimal places here. So 1 divided by 35, it's about 0.0286. 4 divided by 35, 0.1143. 7 divided by 35, it's 0.2000. 10 divided by 35. Okay, 10 divided by 35 is giving me 0.287, not 7, but 57. And then 13 divided by 35, it's giving me 0.3714. Okay, so this is the tabular form of my distribution. Okay, and then from there, we can find the graph. Okay, so the graph, we're just going to draw the, we're just going to draw the the bar graph. Okay, we're just going to draw the bar graph. Okay, so the bar graph is going to be in this form. Okay, it's going to be in this form. So let's okay, we need to keep this. Okay, let me do this. Okay. Okay, then we can erase this. Okay, so that we are able to move this guy here. So we can make him small like that, make him small like that. Okay, so this is the distribution in tabular form. And then we can use it to what? To find in graph form. So I'm going to draw a bar graph. So this will be the y-axis. Okay, and then this here will be the x-axis. So that's what we have. Okay, so here you're going to have y, there you're going to have what? X. So this is going to be 0. So you'll take a look at what you have. So on the x-axis, we're going to put 0, okay, 1, 2, 3, and then 4. That's what we're going to put. Then on the y-axis, we're going to put these values in yellow here, okay? So we are seeing that these values are just increasing here. We had 0.02, 0.11, 0.2, 0.28, 0.3. Okay, so it means you can put your values in terms of maybe 0.5. But if you want, you can show them. You can just show the heights. Okay, you can just show the height. So this 0.02, you can say it's somewhere there. Okay, maybe this is too big. So 0, like that. Okay, so here somewhere you have your 0.02. Or maybe let me just label it. Okay, let me label it to avoid confusion. So this is 0. So I'll label it in 0.05. And then from there, I'm going to 0.10, 0.15, 0.20, 0.25, 0.30, and then 0.35, 0.40. So now let's plot. Okay, so 0, okay, here, this 0 here is going to 0.0286. Okay, so that's somewhere below this value, so it's going to come there. Okay, and then 1 goes to 0.1. Okay, 0.1143. So just slightly above the 0.1. So this one is going to go slightly above the 0.1 like that. And then 2 goes to 0.2. So 2 goes to 0.2. 0.2 is there. That is our 2. And then 3 goes to 0.2857. Okay, so 3 goes to 0.28, somewhere there. Okay, just below the 30. That's where we're going to put the 3. And then for the 4, we're saying 0.37. So 0.37 is going to be above there, above the 0.35 here, like that. Okay, so make sure you draw a nice graph here. Okay, so here I didn't use the straight lines. No wonder it's looking bend. But this is how it's going to be looking. Okay, so this will be in graphical what? In graphical form. So this will be our distribution. All right. We're done with this. Let's look at question C. So question C, they're saying, what are the chances that at least 2 people will go to the clinic between 20 hours and what? 21 hours. Okay, so at least means what? Means that 2 or more people. So we're finding the probability of X being greater than or equal to what? 2. So how are we going to find this? Okay, we're going to add the probability of 2, 3, and 4. So this will be probability of 2 plus probability of 3 plus probability of what? 4. So what is the probability of 2? 7 over 35 plus 3, 10 over 35 plus 4, 13 over what? 35. So let's add this to be 35 over 10 plus this, 17 plus this to just be 30. Okay, and then you punch this on your calculator. It's going to give you 0.8571. So this here is the probability, okay, or the chances that at least 2 people go to the clinic between 20 hours and what? 21 hours. All right, so let's look at question 5 now. Okay, so question 5, they're saying the number of cars entering and leaving Lusaka Medical Apex University premises on a particular day between the hours of 16 hours and should be 18 hours, okay, shows a probability distribution modeled by the function, this one here. So whenever you see something like this is a Poisson. Okay, this is a Poisson because I can see the value that I have there. So this 0.1 here is the mean or the average. It's also there. Okay. When I was talking about question 1, we gave that as a definition, right? Okay. So this is the Poisson distribution. So they're saying where the variable x, this x here denotes the number of cars that enter, okay, and leave Lusaka Apex Medical University between 16 and 18 hours. Okay, question A, it's here, this side. Okay, so question A, they're saying find the probability of 0, find the probability of 1. Okay, so the probability that no car enters is equals to So you just have to replace wherever there's x here, you're going to be putting 0. So it will be 0.1 to the power 0 divided by 0 factorial, then multiplied by e to the power minus 0.1. So this will be, what is any number raised to power 0? 1. Then what is 0 factorial? 0 factorial is 1. Okay, if you don't know, just punch it on your calculator. Then multiplied by e to the power minus 0.1. So this is going to be equals to 1. This is 1. Okay, so this here is be the same as 1 over e to the power 0.1. So what are you going to get there? Okay, so I'm getting the probability 0.0905. So this is the probability that 0 cars will enter or leave Lusaka Medical Apex premises between 16 hours and what? 18 hours. Right, so let's find the probability that 1 car will enter or leave. Okay, so probability of 1 will be equals to 0.1 to the power 1 factorial e to the power 0.1. So this will just be 1 on top, and then 1 factorial is also 1. I mean, on top here, we're going to have 0.1 since it's per power 1. And then down here, we're going to have 1. So 0.1 divided by 1, okay, it's going to give you 0.1. And then that's 0.1 multiplied by e to the power minus 0, 1. So this is going to be equals to 0.1 multiplied by e to the power minus 0.1 is 0.90. And then, okay, and then, okay, and then 4.8. Okay, I think I wrote the wrong number there because my calculator had given me something else now here. So if on the first question I wrote 0.0905, okay, this is not correct on the first question. The right answer should be this one here. So 0.0 0.9048. This is the probability that no cars will enter for the 0. Then for the 1, okay, you're just multiplying the 1 for the 0 multiplied by 0.1 here. So if I multiply this, I'm getting now 0.0905. Okay, so this is the probability that 1 car will enter or leave the premises between what? 16 and 18. Okay, let's solve the last question for this video. Okay, so the last question for this video is B. They're saying find the probability of observing at least 3 cars passing through these premises during the 16 and 18. So observing at least 3 cars. Okay, so at least 3 cars, it means we are finding the probability of 3 or more. But here on the variables here, 3 is the highest, right? So this is just going to be equals to the probability of being 3 because it's the highest there. So this is going to be equals to, okay, we're saying the probability of 3 here just be 0.1 to the power 3 divided by 3 factorial multiplied by e to the power minus 0.1. So let's just punch this onto our calculator and see what we're going to find. Okay, so when I punch this on my calculator, I'm finding 0.00015647. Okay, so round it off to be 0.0002. So this here will be the probability that at least 3 cars, which is just the same as the 3 cars passing through the premises during 18 hours and what? 18 hours. Right, so in this video, we're going to end here. In the next one, we're going to continue from question 6 all the way up to question 10. So thank you so much for watching and all the best in your test ones.